So now we are going to look at all the transformations of the quadratic together. For this example, I have put two of the parent functions on the graph. One is in blue and one is in red. And we are going to move the red one by moving the cursor over the red graph. Now remember that this symbol widens or makes the quadratic thinner. And that changes our number here, which is our A value, okay? Now we want to move it up or down and horizontally, so we look for this cross right here. So when we click that, it's gonna move it up and down and horizontally. So it's gonna move it vertically and horizontally. So if we move the equation over here, we can see that when we have the cross, we're moving it vertically and horizontally, what numbers are changing, and that are these two numbers here, which is our H and our K. So if we move that, we can see those numbers changing. Now, we have it up here, so let's have it up here. Now let's look at our vertex. Our vertex is right here, and it is a minimum. On this graph, it is a minimum because the graph opens up, and that is the lowest point. So if we find the vertex, we can go to Menu, Analyze, and here's where we find the vertex. We have to pick either minimum or maximum, and in this case, it is a minimum, so we're going to pick that. Now we have two graphs on the calculator. So the calculator is asking which graph does it want us to find. Well, we want us to find the vertex of graph 2, the red one. So we're going to click it, and it says lower bound here. So that means the left side of the vertex. So we're going to click on the left side of the vertex, click and hold, and go across the vertex until our vertex numbers show up, and it also says a minimum right there. So if you look at our vertex, we'll put it down here and look at it close to our equation. What do you notice about the numbers? Well, our x value of our vertex is the same as our horizontal change of our h in our equation. And our y value is the same as our k value in our equation. So these two numbers are your vertex. This is your x and this is your y. Now remember that when you move horizontally, it is always the opposite sign. So if this is negative, it's going to be a positive up here, okay? So let's look at another one. I have the same situation up here. We have our new graph that we're going to move. So let's move that red graph, and let's move it over here. So there is our equation. Now in this one, we did not change the a value, so it does not have a number in front of the x squared. So it's the same size as our parent function. So let's go ahead and find the vertex on this one. This is still a minimum, and we want to know the vertex of graph 2. So we're going to click and click again, and here is our vertex. So it is the opposite sign, so it's a negative 4.56 and a negative 1.09. You notice that our our sign here on our k value doesn't change. So let's look at this one now. And let's move it over here. Now let's do one where it is a negative. So if it's negative, we need to change that A and bring it all the way down here where it's negative. So now our A is negative. It opens downward. So instead of a minimum, we're going to have a maximum. So let's find our vertex, Menu, Analyze, Maximum this time. We still want the maximum of the red graph. So now the left side is on this side of the vertex. click here, move across, and there is our maximum. And it's the same. It doesn't matter if it opens up or down. It is the opposite sign of your H, of your horizontal movement, and it's the exact same sign for your vertical movement. The A value does not change, whether it's negative, positive, doesn't matter what the number in front is. Your vertex is always these two numbers. So now let's look at some problems. If we look at these equations and we want to know the vertex of each one just from the equation, remember what we did on the graph, we took the opposite of this, so our horizontal change, which is our x value, is going to be 3, and then our y value, which is our k, is going to be 4. And that is our vertex of that graph. Let's look at this one. The opposite of this is -1. And our y value is -5. Now here we do have an A value. Our 2 is going to make the graph thinner, but it's not going to affect our vertex. So we have a opposite of -4. So we're going to put a +4 for our x value, and then a +3 for our y value. And then on this graph, if you look at our A value, it's a negative. There's no number there, so it's a -1. The negative is going to make the graph open down, but it does not change our vertex, so we take the opposite of +6 for our x value, and then our y value is going to be -7. And that's all there is to find in the vertex from the equation.